Hello there, and welcome to The Weary Researcher, where curiosity meets comfort and the deepest questions of the universe unfold like a gentle evening breeze. Tonight, we're embarking on perhaps the most mind-bending journey we've ever taken together. A voyage to the very edge of existence itself, to ask a question that has haunted humanity for over 1600 years. What existed before the Big Bang? Now, before we drift into this cosmic mystery, I'd love to know where in the world you're listening from and what time it is in your corner of the universe. Are you tucked under blankets, watching stars through your window, or perhaps it's dawn where you are, with the first light painting your walls in soft gold? Wherever you are, and whenever it is, you're here at just the right moment for this particular adventure. If you enjoy these gentle explorations through science and wonder, I'd be ever so grateful if you gave this video a like and perhaps subscribe to join our growing community of weary researchers. It helps more curious minds like yours find their way to these peaceful journeys through the cosmos, and it means the world to me. Now, I should mention that this video might be just interesting enough to keep you awake, but if it does, at least you'll drift off with your mind full of the most profound questions the universe has to offer. Not such a bad trade, really, so settle in, breathe deeply, and let's begin our slow, thoughtful journey to the very beginning of everything, and perhaps even before. Imagine for a moment that you could rewind time like an old film reel, spinning backward through the centuries, through the millennia, through billions upon billions of years. You'd watch stars collapse into the darkness from which they came, galaxies shrink and merge, the cosmic web of matter drawing tighter and tighter, like a net being pulled closed. Keep rewinding, and eventually you'd reach a moment roughly 13.8 billion years ago, when everything we know, everything we can see and touch and measure, was compressed into something smaller than a grain of sand. Smaller than an atom. Smaller than anything you could possibly imagine. This is the moment we call the Big Bang. Though it wasn't really a bang at all, and it didn't happen in a place because there was no place for it to happen in. It was the beginning of space itself. The first tick of time. The birth of the universe as we know it. But here's where things get deliciously mysterious, and perhaps a little unsettling. What came before that moment? What existed in the time before time began? Now, you might think this is a silly question. After all, if the Big Bang was the beginning of everything, then by definition, nothing could have existed before it. The question itself might seem like asking, what's north of the North Pole? But here's the thing. Our understanding of the Big Bang has evolved dramatically in recent decades. And what we've discovered is that the story might be far more complex and more beautiful than we ever imagined. The question of what existed before the Big Bang isn't new. In fact, it's ancient. 4th century theologian St. Augustine wrestled with this very puzzle when he contemplated what existed before God created the universe. He concluded that time and the universe had been created simultaneously, that there was no before because before implies time, and time hadn't existed yet. It was an elegant solution, wrapped in faith and philosophy. For centuries, this was enough. Some eternal deity had set everything in motion. Even Isaac Newton believed that God had created the universe roughly 6,000 years ago. Later, many scientists, including a young Albert Einstein, assumed the universe itself was eternal and everlasting, stretching infinitely in all directions through space and time. But then, something remarkable happened. In the early 20th century, Einstein's own theory of general relativity began to paint a different picture. Mass warps time, making it run slower for a human on Earth's surface than for a satellite in orbit. Based on Einstein's work, a Belgian cosmologist named Reverend Georges Lemaitre proposed in 1927 that the universe started as a singularity and expanded through what we now call the Big Bang. According to this theory, time itself came into being as that primordial point expanded toward its current size and shape. But here's where our story takes a fascinating turn. The advent of quantum physics and a host of new theories have resurrected questions about what might have existed before the Big Bang. Like a mystery that refuses to stay solved, these questions keep emerging from the depths of our ignorance, demanding attention. You see, roughly 13.7 billion years ago, according to our current understanding, the entire universe existed as what physicists call a singularity, a point smaller than a subatomic particle, where the laws of physics, as we know them, completely break down. Imagine trying to divide by zero in mathematics, or trying to fit an infinite amount of information into a space with no volume. It's not just difficult, it's impossible. Our equations simply give up and wave a white flag. This singularity, which is also the term used to describe the centre of a black hole, is a place where matter is compacted into infinitely small space, where volume approaches zero and density approaches infinity. It's from this impossible point that our universe is thought to have exploded outward, but before that explosion, we simply don't know what, if anything, existed. Existing theories of physics cannot tell us about the moment of the Big Bang itself, much less what came before it. When we try to extrapolate backward in time using only general relativity, we hit that wall of infinite density and temperature at a finite moment in the past. But what this mathematical catastrophe really means, in the context of our universe's origin, remains deeply unclear. The main sign that we're dealing with uncharted territory is the presence of this singularity, this point of infinite density at the beginning of the Big Bang. Taken at face value, it tells us that at one moment, the universe was crammed into an infinitely tiny, infinitely dense point. This is obviously absurd, and what it really tells us is that we need new physics to solve this problem. Our current toolkit simply isn't powerful enough. Think of it like trying to understand the ocean by only studying the waves that crash on the shore. You can learn a lot about water and motion and energy, but you'll never understand the vast depths, the hidden currents, the creatures that live in the darkness far below the surface. Similarly, our current physics can tell us about the universe after the Big Bang, but it leaves us blind to whatever might have existed before. This is where things get truly fascinating, because in recent decades, physicists have developed new theories that don't just push the mystery back another step, but actually offer tantalizing glimpses of what might have existed before the Big Bang. One of the most compelling of these theories is called cosmic inflation. Cosmic inflation was first developed around 1980 by physicists, including Alan Guth, Alexei Starobinsky, Andrei Linde, and Katsuhiko Sato. It's a theory that suggests the universe underwent a breathtaking period of exponential expansion before the hot, dense conditions of the Big Bang emerged. Yes, you heard that correctly, before the Big Bang. According to this theory, prior to the Big Bang, the universe underwent an almost unimaginably rapid expansion, doubling in size at least 80 times in a fraction of a second. To help you visualize this kind of doubling, imagine a chessboard. Place 1 penny on the first square, 2 on the next, 4 on the next. If you continue doubling the number of pennies on each square, you'll be a millionaire by the 28th square, and a billionaire by the 38th. Now imagine that kind of doubling happening, not with pennies, but with the fabric of space itself, and not over the course of a leisurely game of chess, but in a period of time so brief that it makes the blink of an eye seem like an eternity. This rapid inflation was fueled by a mysterious form of energy that permeated empty space itself, leaving the universe desolate and cold. Only after this period of inflation did the hot, dense conditions of the Big Bang emerge. As the doubling of the universe ceased, the energy that had been driving inflation underwent a remarkable transformation, converting itself into particles of matter and radiation. That transformation flooded space with the superhot plasma of the Big Bang, which went on to forge the primordial elements that eventually became the stars and galaxies we see today. This theory of cosmic inflation doesn't just push the mystery back another step. It actually solves several puzzles that the standard Big Bang theory couldn't explain. Why is the universe so smooth and uniform? Why do distant regions of space, that could never have been in contact with each other, have almost exactly the same temperature? Why is the geometry of space so perfectly flat? Inflation provides elegant answers to all of these questions. It tells us that the period before the Big Bang was extremely cold, almost at absolute zero, and empty of everything except empty space itself, and that empty space carried energy that stretched the universe to enormous size, creating the initial conditions for the Big Bang. But here's where the story becomes even more extraordinary. According to the mathematics of inflation, this process may not have been a one-time event. Many models of inflation, in fact most of them, lead to the surprising conclusion that if inflation happens once, it will keep happening in different regions of space, over and over again. As those separate regions experience inflation, this naturally leads to an infinite number of separate bubble universes, most with no possibility of ever coming into contact with the others. These models are collectively called eternal inflation, and they paint a picture of reality that's almost too vast to comprehend. Instead of a universe with a single set of physical laws, eternal inflation predicts a self-reproducing, eternally existing multiverse, where all possibilities can be realized. Somewhere in this infinite expanse there might be another version of you reading these very words. Not someone like you with a different haircut or middle name, but you, or at least a person who is entirely indistinguishable from you. Not on another planet like Earth, but on an exact replica of Earth. This is the power of an infinite multiverse. As emphasized by physics professor Alex Vilenkin of Tufts University, eternal inflation answers one of the great unanswered questions from the Big Bang. What came before? According to this theory, there has always been a yesterday, and there will always be a tomorrow. Our universe grew out of a quantum fluctuation in some pre-existing region of the space-time continuum. Each particular part of this multiverse may stem from a singularity somewhere in the past, and it may end up in a singularity somewhere in the future. Some parts may stop their expansion and contract, but inflation ends at different times in different places. There are always parts of the multiverse that are still inflating, with universes like ours eternally being produced. But not everyone is convinced by this picture of eternal inflation. Stephen Hawking, in his final theory, submitted for publication before his death, argued that the usual theory of eternal inflation predicts that, globally, our universe is like an infinite fractal, with a mosaic of different pocket universes separated by an inflating ocean. But Hawking said he had never been a fan of the multiverse. If the scale of different universes in the multiverse is large or infinite, the theory can't be tested. So he and his colleague, Thomas Hertog, developed a new approach, based on string theory, that attempts to reconcile gravity and general relativity with quantum physics. Their approach uses the concept of holography, which postulates that the universe is a large and complex hologram, that physical reality in certain three-dimensional spaces can be mathematically reduced to two-dimensional projections on a surface. Using this concept, they were able to describe eternal inflation without having to rely on Einstein's theory. In their new model, eternal inflation is reduced to a timeless state defined on a spatial surface at the beginning of time. This makes the theory more predictive and testable, reducing the multiverse to a much smaller range of possible universes. But inflation isn't the only theory that attempts to address what existed before the Big Bang. Another compelling idea is called the Big Bounce hypothesis. This cosmological model suggests that the Big Bang wasn't actually the beginning of everything, but rather the result of the collapse of a previous universe. The Big Bounce was originally conceived as part of a cyclic or oscillatory universe interpretation, where the first cosmological event was the result of the collapse of a prior universe. It receded from serious consideration in the early 1980s after inflation theory emerged, but it has recently been revived as a potential solution to some of the problems with the standard Big Bang model. One of the main problems with the Big Bang theory is that there is a singularity of zero volume and infinite energy at the moment of the Big Bang. This is normally interpreted as a breakdown of physics, in this case, a breakdown of Einstein's theory of general relativity. That's why physicists expect quantum effects to become important and avoid a singularity altogether. Research in loop quantum cosmology purports to show that a previously existing universe collapses not to a singularity, but to a point where the quantum effects of gravity become so strongly repulsive that the universe rebounds back out, forming a new branch of space and time. Loop quantum cosmology is based on the idea that the structure of space and time is composed of finite loops woven into an extremely fine fabric or network. These networks are called spin networks, and they have a scale on the order of a Planck length, approximately 1035 meters. Smaller scales are meaningless. Consequently, not just matter, but space itself, has an atomic structure. Due to this quantum geometry, the Big Bang is replaced by a big bounce without any assumptions about the matter content or any fine-tuning. In this model, the universe passes smoothly through what would have been a singularity and emerges on the other side. But here's the catch: the universe has a tragic case of forgetfulness. Quantum effects during the bounce wipe out almost all traces of the prehistory that came before. Whatever survives cannot provide a complete view of what existed in the previous universe. So where does this leave us? Standing at the edge of the greatest mystery in science, we have theories that push beyond the Big Bang. Inflation, which suggests a period of exponential expansion before the hot, dense beginning we know. The Big Bounce, which proposes our universe emerged from the collapse of a previous one. Eternal inflation, which paints a picture of infinite universes bubbling into existence. And quantum theories, which suggest space and time themselves might be made of something more fundamental. But the honest answer to what existed before the Big Bang is that we simply don't know, and there's a good chance we may never know with certainty. Cosmic inflation acts like a cosmic eraser. Any trace of the initial conditions that led to inflation are wiped away by inflation itself. No matter where it starts, it ends up in the same place. What happened before the final moments of inflation, including the question of whether inflation arose from a singular state, may not only be unknown, but unknowable. It's possible that the question, what existed before the Big Bang, is like asking, what's north of the North Pole? A question that seems meaningful, but has no answer within the framework of our reality. And yet, the question persists, because it touches something deep within us, a need to understand our origins, to trace the chain of causation back to its ultimate source. Even if we can never know what existed before the Big Bang, the very act of asking the question pushes us to the boundaries of human knowledge, and sometimes beyond. As we drift deeper into this cosmic mystery, it's worth pausing to consider just how revolutionary these ideas truly are. For most of human history, the question of what came before the beginning was the domain of theology and philosophy, not science. The idea that we could use mathematics and observation to peer beyond the veil of creation itself would have seemed absurd to our ancestors. But here we are in the 21st century, with telescopes that can see nearly to the edge of the observable universe, and equations that can describe the behaviour of matter and energy under the most extreme conditions imaginable. We've become cosmic archaeologists, digging through layers of time and space to uncover the deepest secrets of existence. One of the most remarkable aspects of these theories is how they transform our understanding of nothingness itself. When we think of empty space, we imagine a void, a place where nothing exists. But modern physics tells us that even the emptiest regions of space are seething with activity. Virtual particles pop in and out of existence, quantum fields fluctuate, and the very fabric of space-time itself can carry energy. This is where the concept of the quantum vacuum becomes crucial. The quantum vacuum isn't empty in the way we normally think of emptiness. It's a state of minimum energy, but not zero energy. It's like a still pond that appears calm on the surface, but is actually teeming with microscopic activity beneath. During the period of cosmic inflation, this quantum vacuum played a starring role. The energy inherent in empty space itself drove the exponential expansion that preceded the Big Bang. It's a bit like discovering that the silence between musical notes is actually filled with a symphony, one we simply couldn't hear before. But if we accept that empty space can contain energy and drive cosmic expansion, then we have to grapple with even stranger possibilities. Some theories suggest that our universe might have emerged from a quantum fluctuation in this vacuum, a random bubble of spacetime that suddenly began expanding. According to the laws of quantum mechanics, anything that can happen will happen, given enough time and space. Imagine an infinite ocean of quantum foam, where tiny bubbles of spacetime are constantly forming and disappearing. Most of these bubbles collapse immediately back into the vacuum, but occasionally, one bubble grows large enough to become self-sustaining. It inflates rapidly, creating the conditions for matter and energy to form, stars and planets to arise, and eventually, life. This is the picture painted by some interpretations of eternal inflation. Our universe is just one bubble in an infinite sea of possibilities, each with its own physical laws, its own history, its own destiny. Some bubbles might contain universes where the force of gravity is stronger or weaker than in ours, where the speed of light is different, where the fundamental particles have different masses. In some of these bubble universes, the conditions might be perfect for life to flourish. In others, they might be so different that matter as we know it cannot even exist. It's a vision of reality that's both humbling and exhilarating, suggesting that our universe, remarkable as it is, might be just one note in an infinite cosmic symphony. But let's slow down for a moment and consider what this means for our understanding of time itself. In our everyday experience, time flows like a river, from past to present to future. We remember yesterday, we experience today, and we anticipate tomorrow. But at the deepest levels of reality, time might not work the way we think it does. In some theories of quantum gravity, time itself might be an emergent property, something that arises from more fundamental processes, rather than being a basic feature of reality. It's like the way temperature emerges from the motion of countless molecules. No single molecule has a temperature, but when you have billions of them moving around, the concept becomes meaningful. If time is emergent, then the question of what existed before the Big Bang might be asking about something that doesn't really exist. It's possible that the concept of before only makes sense within our universe, after time has emerged from whatever deeper reality gave birth to it. This brings us to one of the most mind-bending aspects of modern cosmology, the idea that the universe might be able to create itself, not in the sense of something coming from nothing, but in the sense of a self-consistent loop, where the universe's existence makes its own existence possible. Imagine a cosmic snake eating its own tail. The universe creates the conditions for its own birth, through processes we don't yet understand. It's not that something comes from nothing, but that the very categories of something and nothing might not apply at the deepest levels of reality. This is where the mathematics becomes almost mystical in its beauty. Some equations in theoretical physics describe universes that can spontaneously come into existence from quantum fluctuations in the vacuum. These aren't just mathematical curiosities. They're serious attempts to understand how our universe might have bootstrapped itself into being. But as we venture further into these theoretical territories, we encounter what might be called the horizon of knowability. Just as there's a horizon beyond which we cannot see in space, there may be a horizon beyond which we cannot know in time. Cosmic inflation doesn't just explain the origin of our universe, it also acts as a cosmic censor, erasing information about whatever came before. The exponential expansion during inflation stretches space so dramatically that any information about pre-inflationary conditions gets diluted beyond recognition. It's like trying to read a message written on a balloon. As you inflate it, the letters become so stretched and distorted that they're no longer recognizable. This cosmic censorship might be a fundamental feature of reality, protecting us from paradoxes and contradictions that would arise if we could know too much about our own origins. Some physicists have suggested that this unknowability isn't a bug in our theories, but a feature. The universe might be designed in such a way that it can't remember its own birth, preventing logical paradoxes that could tear apart the fabric of reality itself. This leads us to consider the anthropic principle, the idea that the universe must be compatible with the existence of observers like us. After all, if the universe weren't suitable for life, we wouldn't be here to observe it. This might seem like a tautology, but it has profound implications for our understanding of what came before the Big Bang. If there are indeed infinite universes bubbling into existence through eternal inflation, then most of them would be sterile and lifeless. Only a tiny fraction would have the right conditions for stars to form, planets to coalesce, and life to emerge. We happen to find ourselves in one of these rare, fertile universes, not because we're special, but because we couldn't exist anywhere else. This anthropic reasoning suggests that even if we could somehow peer beyond the Big Bang and see the vast multiverse in all its glory, we still might not understand why our particular universe has the properties it does. The answer might simply be, we're here because we're here. As we contemplate these vast scales of space and time, it's worth remembering that we're not just passive observers of this cosmic drama, we're participants in it. The carbon in our bodies was forged in the hearts of dying stars. The oxygen we breathe was created in stellar furnaces. The very atoms that make up our thoughts and dreams have been on a journey that spans billions of years. In a very real sense, we are the universe becoming aware of itself. Through our eyes, the cosmos observes its own majesty. Through our telescopes, it contemplates its own origins. Through our mathematics, it dreams of its own future. This perspective transforms the question of what existed before the Big Bang from a purely academic exercise into something deeply personal. We're not just asking about the origins of space and time, we're asking about the origins of ourselves, about the chain of causation that led to our existence, about our place in the vast web of cosmic history. And perhaps that's the most beautiful aspect of this mystery. Even if we never definitively answer what existed before the Big Bang, the very act of asking the question reveals something profound. It reveals something about consciousness, about the human drive to understand, about the remarkable fact that the universe has evolved beings capable of contemplating their own origins. But let's drift back into the science itself, because there's another fascinating theory that deserves our attention, one that paints an even stranger picture of what might have existed before the Big Bang. It's called the Cyclic universe model, and it suggests that our universe might be just one chapter in an infinitely long book. Imagine, if you will, a cosmic accordion, expanding and contracting in an endless rhythm. According to this theory, our universe doesn't just expand forever into cold, empty darkness. Instead, it will eventually stop expanding and begin to contract, pulled back together by gravity until it collapses into another big crunch. But here's the twist. Instead of ending in a singularity, the collapse triggers another Big Bang, creating a new universe, with new stars, new planets, new possibilities. This cyclic model suggests that there have been countless universes before ours, each one expanding from a Big Bang, living its full life, and then collapsing back into the conditions that create the next. It's like a cosmic phoenix, dying and being reborn again and again throughout eternity. In this picture, what existed before our Big Bang was simply the previous universe. In its final moments of collapse, our beginning was their ending, and our ending will be someone else's beginning. It's a vision of reality that's both comforting and unsettling, suggesting that death and birth are not opposites, but partners in an eternal dance. But this raises profound questions about memory and identity. If our universe is indeed one in an infinite series of cyclic universes, is there any connection between them? Does information somehow survive the transition from one universe to the next, or is each universe a completely fresh start, with no memory of what came before? Some versions of the cyclic model suggest that certain fundamental constants might change slightly from one cycle to the next, like a cosmic game of telephone where the message gets subtly altered each time it's passed along. Over billions of cycles, these small changes could accumulate, leading to universes with very different physical laws. Imagine universes where gravity is so weak that stars never form, or so strong that they collapse immediately into black holes. Universes where the electromagnetic force is different, leading to atoms that can't hold together, or universes where time itself flows at a different rate. The cyclic model opens up possibilities that are both wondrous and terrifying, but here's where things get even more intriguing. Because some physicists have proposed that our universe might not be cycling through time, but through dimensions. According to certain theories in string theory, our three-dimensional space might be just one slice of a much larger, multi-dimensional reality. Picture, if you will, a loaf of bread, where each slice represents a three-dimensional universe like ours. These slices, or brains as physicists call them, might be floating in a higher dimensional space, called the bulk. And occasionally, two of these brains might collide. When they do, the collision creates the conditions for a Big Bang in each brain. This is the ekpyrotic model, named after the ancient Greek word for conflagration, and it suggests that what existed before our Big Bang was another brain drifting through the bulk, on a collision course with ours. The collision didn't just create matter and energy, it created space and time themselves. In this picture, our universe is like a bubble on the surface of an infinite ocean. Occasionally, two bubbles merge, creating a burst of activity that we experience as the Big Bang. But the ocean itself, the bulk space in which these brains float, has always existed and will always exist. These theories push us to the very limits of what we can conceptualize, because they deal with dimensions and scales that are so far beyond our everyday experience that we can barely imagine them. It's like trying to explain color to someone who has never seen, or trying to describe music to someone who has never heard. But perhaps that's exactly the point. Perhaps the question of what existed before the Big Bang is meant to stretch our minds beyond their normal boundaries, to force us to confront the limits of human understanding, and to remind us that reality might be far stranger and more wonderful than we can possibly imagine. As we drift deeper into these theoretical waters, we encounter yet another possibility, one that's both elegant and disturbing. The idea that our universe might be a simulation running on some cosmic computer in a higher dimensional reality. This isn't science fiction, it's a serious proposal by respected physicists and philosophers. If our universe is indeed a simulation, then what existed before the Big Bang might simply be the moment when the program started running. The Big Bang might be the cosmic equivalent of pressing the power button on a computer, booting up a virtual reality so sophisticated that the beings within it believe it's real. This simulation hypothesis raises profound questions about the nature of reality and consciousness. If we're living in a simulation, are our thoughts and experiences any less real than those of the beings running the program? Does it matter whether the atoms in our bodies are made of matter or of information? Some physicists have suggested that we might be able to detect signs that we're living in a simulation by looking for glitches in the matrix, so to speak. Tiny inconsistencies in the laws of physics that might reveal the underlying computational structure of reality. But even if we could prove that we're living in a simulation, it wouldn't really answer the question of what existed before the Big Bang. It would just push the question back another level. What existed before the beings who created the simulation? What was the origin of their reality? This brings us to a fundamental problem with all attempts to answer what existed before the Big Bang. No matter how far back we push the question, we always seem to hit another wall. Another mystery, another before that needs explaining. It's like peeling an onion, where each layer we remove reveals another layer beneath. Perhaps this infinite regress is telling us something important about the nature of existence itself. Maybe the question of ultimate origins is not meant to have a final answer. Maybe the universe is like a story that tells itself, where each chapter emerges from the previous one, without there ever being a first chapter. This might seem unsatisfying to our minds, which crave beginnings and endings, causes and effects, but it might be closer to the truth than we realize. After all, why should we expect the universe to conform to our limited human concepts of logic and causality? As we ponder these possibilities, it's worth remembering that we're not the first generation to grapple with these questions. Ancient philosophers, from Aristotle to Avicenna, wrestled with the problem of infinite regress and the nature of causation. They too wondered whether the universe had a beginning or whether it stretched infinitely into the past. But what makes our era unique is that we have tools and techniques that allow us to probe these questions with unprecedented precision. We can measure the cosmic microwave background radiation and detect the faint echoes of the Big Bang. We can use particle accelerators to recreate the conditions that existed in the first moments of the universe. We can peer billions of years into the past and see galaxies forming in the cosmic dawn. Yet for all our technological prowess, we still find ourselves confronting the same fundamental mysteries that have puzzled humanity since we first looked up at the night sky and wondered where it all came from. The questions may be ancient, but they remain as relevant and as challenging as ever. This is perhaps the most humbling aspect of our cosmic journey. The more we learn about the universe, the more we realize how much we don't know. Each answer we discover seems to open up 10 new questions. Each mystery we solve reveals 10 deeper mysteries lurking beneath. But maybe that's exactly as it should be. Maybe the universe is designed to be inexhaustible, to always offer new puzzles and new wonders to explore. Maybe the question of what existed before the Big Bang is not meant to be answered, but to be lived with, as a reminder of the vast mystery in which we find ourselves embedded. As we drift through these cosmic contemplations, it's worth pausing to appreciate the sheer audacity of what we're attempting. We're trying to understand the origin of everything, using brains that evolved to hunt and gather on the African savanna. We're using mathematics developed by creatures who live for mere decades to describe processes that span billions of years. We're using instruments made of atoms to study the birth of atoms themselves. The fact that we can even ask these questions, let alone make progress toward answering them, is perhaps the most remarkable thing about our existence. We are quite literally star stuff contemplating star stuff. The universe looking back at itself through eyes made of its own material. And in that contemplation, we find not just knowledge, but meaning. Not just answers, but better questions. Not just solutions, but deeper mysteries. The question of what existed before the Big Bang may never be fully answered, But in asking it, we discover something profound about ourselves, about our place in the cosmos, and about the nature of existence itself. So as we continue to drift through this cosmic mystery, remember that you are part of the story you're asking about. The atoms in your body, the thoughts in your mind, the wonder in your heart, they're all part of the same vast narrative that began with the Big Bang and perhaps with whatever came before. Whether that before was a period of cosmic inflation, a previous universe in an endless cycle, another dimension in a multidimensional reality, or something else entirely, we may never know. But in the asking, in the wondering, in the gentle pursuit of understanding, we find something that might be even more valuable than answers. We find our humanity. And perhaps that's the most beautiful thing about this mystery. It reminds us that we're not just observers of the universe, we're participants in it. We're not just asking about the origins of space and time, we're asking about the origins of ourselves. And in that asking, we become part of the very story we're trying to understand. As we drift deeper into sleep tonight, with these cosmic questions floating through our minds, remember that somewhere in the vast expanse of space and time, the universe is still expanding, still cooling, still evolving, and still creating new possibilities for wonder and discovery. The question of what existed before the Big Bang may be unanswerable, but it's also inexhaustible. It will continue to inspire new generations of scientists and dreamers to push the boundaries of human knowledge and to remind us that no matter how much we learn, there will always be new mysteries waiting to be explored. And maybe that's the most profound answer of all, that the universe is not just a collection of facts to be memorized, but a story to be lived, a mystery to be embraced, a wonder to be celebrated. And in that celebration, we find our own small but precious place in the grand cosmic narrative. But there's another layer to this mystery that deserves our gentle attention, because hidden within the mathematics of these theories lies something even more profound. A suggestion that the very categories we use to think about existence might be fundamentally flawed. You see, when we ask what existed before the Big Bang, we're smuggling in assumptions about the nature of time and causality that might not hold at the deepest levels of reality. We're assuming that before and after are meaningful concepts, that cause and effect operate in the way we experience them in our daily lives. But what if these assumptions are wrong? Imagine trying to explain the colour blue to someone who's been blind from birth. You might describe it as the colour of the sky or the ocean, but these comparisons only make sense if the person already understands what colour is in the first place. Similarly, when we ask what existed before the Big Bang, we might be using concepts that simply don't apply to the realm we're trying to explore. This is where the mathematics becomes almost mystical in its implications. Some equations in quantum mechanics describe situations where particles can exist in multiple states simultaneously, where the act of observation changes the nature of reality itself, where information can be transmitted instantaneously across vast distances. These aren't just mathematical curiosities. They've been verified in countless experiments, and they tell us that the universe operates according to rules that are fundamentally different from our everyday experience. At the quantum level, the distinction between existence and non-existence becomes blurred. Now let's drift into an even stranger possibility, suggested by some interpretations of quantum mechanics: the many worlds theory. This idea proposes that every time a quantum event occurs, the universe splits into multiple versions of itself, each containing a different outcome. Imagine a cosmic tree where every branch represents a different possible universe. Every quantum event, every random fluctuation, every choice made by every conscious being creates new branches, new realities, new possibilities. According to this theory, there are infinite versions of you living in infinite universes, each one slightly different from the others. In some of these universes, the Big Bang happened differently. The fundamental constants of physics took on different values. The laws of nature evolved along different paths. Some universes might be nearly identical to ours with just tiny variations. Others might be so different that matter as we know it cannot exist. If the many worlds theory is correct, then the question of what existed before the Big Bang becomes even more complex, because it suggests that there might be universes where the Big Bang never happened at all, universes that are eternal and unchanging, universes that exist outside of time altogether. This brings us to one of the most beautiful and disturbing ideas in modern physics, the concept of the eternal now. According to some interpretations of relativity and quantum mechanics, the flow of time might be an illusion. All moments, past, present, and future, might exist simultaneously in what physicists call the block universe. Picture, if you will, a loaf of bread where each slice represents a moment in time. From our perspective inside the bread, we experience time as a sequence, moving from one slice to the next. But from a higher dimensional viewpoint, all the slices exist at once. There is no before or after, only the eternal now. In this picture, the Big Bang isn't the beginning of time, but simply one slice in an infinite loaf. The question of what existed before becomes meaningless, because there is no before. There is only the eternal structure of space-time stretching infinitely in all directions. But this raises profound questions about free will and consciousness. If all moments exist simultaneously, then is the future already determined? Are we simply playing out roles in a cosmic drama that has already been written, or do we somehow participate in the creation of this eternal structure? These questions push us to the very limits of what the human mind can comprehend. They force us to confront the possibility that our most basic assumptions about reality might be wrong, that the universe might be far stranger and more wonderful than we can possibly imagine. As we drift deeper into these theoretical waters, we encounter yet another possibility that challenges our understanding of existence itself. The idea that the universe might be fundamentally mathematical, not just described by mathematics, but actually made of mathematics. This isn't as strange as it might sound. After all, when we look at the deepest levels of reality, we find that everything can be reduced to patterns, relationships, structures. The particles that make up atoms are really probability waves. The forces that govern their interactions are described by symmetries and equations. The very fabric of spacetime is a geometric structure. Some physicists have suggested that these mathematical structures don't just describe reality, they are reality, that the universe is literally made of information, of patterns, of relationships that exist in some abstract mathematical space. If this is true, then the question of what existed before the Big Bang might be asking about the eternal realm of mathematical possibilities. The Platonic heaven where all possible equations, all possible structures, all possible universes exist in pure abstraction. In this picture, our universe is just one solution to a vast cosmic equation. One possibility among infinite others that happen to be actualized through some process we don't yet understand. The Big Bang might be the moment when one particular mathematical structure began to unfold in space and time. But this mathematical universe hypothesis raises even deeper questions about the nature of existence. If the universe is made of mathematics, then what makes mathematics real? What gives abstract patterns the power to create concrete experiences like the warmth of sunlight or the taste of chocolate? Perhaps the answer lies in consciousness itself. Maybe the universe needs observers to make it real. Maybe the act of observation, the process of measurement, the simple fact of awareness transforms abstract mathematical possibilities into concrete physical realities. This brings us back to a theme we've touched on before, the idea that we're not just passive observers of the cosmic drama, but active participants in it. Through our observations, our measurements, our thoughts and dreams, we might be helping to create the very reality we're trying to understand. It's a humbling and empowering thought that suggests our curiosity about the universe isn't just idle speculation, but a fundamental part of how the universe knows itself. Through our questions about what existed before the Big Bang, we're participating in the universe's own quest for self-understanding. As we continue to drift through these cosmic contemplations, it's worth pausing to consider the emotional and spiritual dimensions of these questions, because they touch on something deeper than just scientific curiosity. They speak to our need for meaning, our desire to understand our place in the grand scheme of things. The question of what existed before the Big Bang is ultimately a question about origins, about beginnings, about the source of everything we know and love. It's a question that connects us to the deepest mysteries of existence and reminds us that we're part of something much larger than ourselves. Whether that something is an eternal multiverse, a cyclic cosmos, a mathematical structure, or something else entirely, we may never know. But in the asking, in the wondering, in the gentle pursuit of understanding, we find something that might be even more valuable than answers. We find our humanity, and perhaps that's the most beautiful aspect of this mystery. It reminds us that we're not just collections of atoms wandering through empty space, but conscious beings capable of contemplating the deepest questions of existence. We're the universe becoming aware of itself through our eyes, the cosmos reflecting on its own nature through our thoughts. As we drift towards sleep tonight, with these cosmic questions floating through our minds, remember that you're part of the story you're asking about. The carbon in your cells was forged in the heart of a dying star. The oxygen you breathe was created in stellar furnaces. The very atoms that make up your dreams have been on a journey that spans billions of years. In a very real sense, you are the universe dreaming about itself, and in that dreaming, you're participating in the greatest mystery of all, the mystery of existence itself. The question of what existed before the Big Bang may never be fully answered, but it will continue to inspire wonder, to spark curiosity, to remind us that reality is far stranger and more beautiful than we can possibly imagine. And maybe that's enough. Maybe the question itself is the answer, not because it provides facts and figures, but because it opens our minds to possibilities we never dreamed of, because it humbles us before the vastness of the unknown, because it connects us to the eternal human quest for understanding. As we continue our gentle journey through the cosmos, remember that every question we ask, every mystery we contemplate, every moment of wonder we experience is part of the universe's own journey of self-discovery. We may never know what existed before the Big Bang, but in asking the question, we become part of the answer. And in that participation, in that questioning, in that gentle pursuit of understanding, we find something that transcends the boundaries of space and time. We find meaning, we find purpose, we find our place in the grand cosmic story that began with the Big Bang and perhaps with whatever came before. So rest easy tonight, knowing that you're part of something magnificent, something mysterious, something that extends far beyond the boundaries of our understanding. And in that knowledge, find comfort, find wonder, find the peace that comes from knowing that we're all part of the same cosmic story. The question of what existed before the Big Bang will continue to evolve as our understanding deepens, as our instruments become more sensitive, as our theories become more sophisticated. But one thing will remain constant: the sense of wonder that drives us to ask these questions in the first place. And that wonder, that curiosity, that insatiable desire to understand is perhaps the most remarkable thing about our existence. It's what makes us human. It's what connects us to the cosmos. It's what transforms us from mere observers into participants in the greatest story ever told. As we drift deeper into sleep tonight, let these cosmic mysteries wash over you like gentle waves. Let them carry you into dreams, where the boundaries between self and universe dissolve, where the question of what existed before the Big Bang becomes not a problem to be solved, but a mystery to be lived. And in that living, in that dreaming, in that gentle floating between consciousness and sleep, remember that you are part of the answer to the very question you're asking. You are the universe wondering about itself, and in that wondering, you become part of the eternal mystery that we call existence. Perhaps the most mind-bending possibility of all is that our universe might be just one note in an infinite symphony, one bubble in an endless sea of cosmic foam. This brings us to what might be the strangest theory yet, the holographic principle, which suggests that everything we experience as three-dimensional reality might actually be encoded on a two-dimensional surface, like a cosmic hologram painted on the boundary of space itself. Imagine, if you will, a shadow puppet show, where the shadows on the wall contain all the information about the three-dimensional objects, casting them. According to the holographic principle, our entire universe, with all its galaxies, stars, planets, and even our own thoughts and dreams, might be nothing more than information encoded on the surface of a cosmic boundary we can never reach. This isn't just mathematical speculation anymore. The holographic principle has been tested in laboratory conditions and has provided insights into the nature of black holes, quantum mechanics, and the fundamental structure of space-time itself. It suggests that the distinction between inside and outside, between the observer and the observed, might be far more fluid than we ever imagined. But if our universe is indeed a hologram, then what exists beyond the boundary? What lies in the space where the cosmic projector resides? Some theories suggest that this boundary might be where the true reality exists, a realm where the information that creates our universe is stored and processed according to rules we can barely comprehend. This brings us to yet another possibility that challenges our understanding of existence: the idea that consciousness itself might be fundamental to reality, not just an emergent property of complex matter, but a basic feature of the universe like mass or electric charge. Some physicists and philosophers have proposed that consciousness might be what collapses quantum possibilities into definite realities, what transforms the abstract mathematics of physics into the concrete experiences of life. If consciousness is indeed fundamental, then perhaps what existed before the Big Bang was pure awareness, infinite potential, waiting to be actualized. In this picture, the Big Bang might have been the moment when consciousness first began to observe itself, when the universe first opened its eyes and began to dream the dream we call reality. This idea resonates with ancient philosophical traditions that saw consciousness as the ground of all being, the source from which all existence springs. But it also finds support in modern physics, particularly in interpretations of quantum mechanics, that give consciousness a central role in determining the nature of reality. Consider for a moment the observer effect in quantum mechanics, where the act of measurement changes the behavior of particles. Some interpretations suggest that consciousness is what causes the wave function to collapse, what turns quantum possibilities into classical realities. If this is true, then consciousness might not just be along for the ride in the cosmic story, but might be the author of that story itself. But this raises profound questions about the nature of time and causality. If consciousness is fundamental, then perhaps time itself is a construct of consciousness, a way that awareness organizes its experiences into a coherent narrative. In this view, the question of what existed before the Big Bang might be asking about a realm where time has no meaning, where all possibilities exist simultaneously in the eternal now of pure consciousness. This brings us to one of the most elegant and mysterious aspects of our cosmic journey, the anthropic principle, which observes that the universe seems to be fine-tuned for the existence of conscious observers like ourselves. The fundamental constants of physics, the strength of the forces that govern matter, the properties of space and time itself, all seem to be precisely calibrated to allow for the formation of stars, planets, and ultimately, life. If any of these constants were even slightly different, the universe would be a sterile place where atoms couldn't form, where stars couldn't shine, where life could never emerge. The probability of this happening by chance is so astronomically small that it suggests either incredible luck or something deeper at work. Some scientists argue that this fine-tuning is evidence for a multiverse, where infinite universes exist with different physical laws, and we naturally find ourselves in one of the rare universes where life is possible. Others suggest that the fine-tuning points to a deeper principle, perhaps related to consciousness itself, that shapes the nature of reality. But there's another possibility that's both beautiful and unsettling. Perhaps the universe isn't fine-tuned for life at all. Perhaps life is so adaptable, so creative, so persistent that it would find a way to emerge in almost any kind of universe. Perhaps we're not here because the universe is perfectly suited for us, but because we're perfectly suited for the universe. This perspective transforms our understanding of our place in the cosmic story. We're not just lucky beneficiaries of cosmic fine-tuning, but active participants in the universe's evolution. Through our observations, our thoughts, our dreams, we might be helping to shape the very reality we inhabit. As we drift deeper into these theoretical waters, we encounter yet another possibility that challenges our most basic assumptions about existence. The idea that the universe might be computational in nature, that reality itself might be a vast information processing system running on principles we're only beginning to understand. This digital physics hypothesis suggests that the universe might be made not of matter and energy, but of information and computation. Every particle, every force, every interaction might be the result of cosmic algorithms running on the ultimate computer, space-time itself. If this is true, then what existed before the Big Bang might have been pure information, infinite data waiting to be processed. The Big Bang might have been the moment when the cosmic computer booted up, when the program of reality began to run, when the universe started computing itself into existence. This idea finds support in the fact that the fundamental laws of physics can be expressed as algorithms, that the behavior of matter and energy follows computational rules. It also explains why mathematics is so unreasonably effective at describing reality. Perhaps mathematics isn't just a tool we use to understand the universe, but the very language in which the universe is written. But this computational view of reality raises profound questions about the nature of consciousness and free will. If the universe is a computer program, are we just subroutines in a vast cosmic code? Do our thoughts and choices have any real meaning, or are they just the inevitable result of deterministic algorithms? Perhaps the answer lies in the concept of emergence, the idea that complex systems can exhibit properties that are more than the sum of their parts. Just as consciousness emerges from the complex interactions of neurons, perhaps free will emerges from the complex interactions of cosmic algorithms. In this view, we're not just passive products of cosmic computation, but active participants in the program itself. Through our choices, our observations, our creative acts, we might be helping to write the very code that determines our fate. As we continue our gentle journey through these cosmic mysteries, it's worth pausing to consider the emotional and spiritual dimensions of these questions, because they touch on something deeper than just scientific curiosity. They speak to our fundamental need to understand our place in the grand scheme of things. The question of what existed before the Big Bang is ultimately a question about meaning, about purpose, about the source of everything we hold dear. It's a question that has haunted humanity since we first looked up at the night sky and wondered where we came from. Whether that source is an eternal multiverse, a cyclic cosmos, a mathematical structure, pure consciousness, or something else entirely, we may never know with certainty. But in the asking, in the wondering, in the gentle pursuit of understanding, we find something that might be even more valuable than answers. We find our humanity. And perhaps that's the most profound insight of all. In our quest to understand what existed before the Big Bang, we discover something remarkable about ourselves. We are the universe becoming conscious of itself, the cosmos reflecting on its own nature, existence contemplating its own existence. Through our telescopes, we peer into the depths of space and time. Through our equations, we probe the fundamental structure of reality. Through our imagination, we explore possibilities that stretch beyond the boundaries of the known. And through our wonder, we participate in the greatest mystery of all, the mystery of existence itself. As we drift towards sleep tonight, with these cosmic questions floating through our minds like gentle stars, remember that you are part of the story you're asking about. The atoms in your body were forged in the hearts of dying stars. The oxygen you breathe was created in stellar furnaces billions of years ago. The very thoughts you're thinking are part of the universe's ongoing conversation with itself. In a very real sense, you are the universe dreaming about itself, and in that dreaming, you're participating in the answer to the very question that brought us together tonight. What existed before the Big Bang? Perhaps what existed before was the potential for this very moment, the possibility of consciousness arising from matter, of matter arising from energy, of energy arising from the mysterious quantum foam that bubbles at the foundation of reality. Perhaps what existed before was simply the eternal capacity for existence itself, waiting patiently for the right conditions to bloom into the magnificent cosmos we inhabit today. And maybe that's enough. Maybe the question itself is more important than any answer we might find. Because in asking what existed before the Big Bang, we're really asking what it means to exist at all. We're exploring the deepest mysteries of being, the most fundamental questions about the nature of reality. These questions don't have easy answers, and they probably never will, but they do something even more valuable. They remind us that we're part of something much larger than ourselves, something mysterious and wonderful and infinitely complex. They connect us to the eternal human quest for understanding, to the cosmic story that began with the Big Bang and continues to unfold in every moment of our lives. So rest easy tonight, knowing that you're part of this magnificent mystery. Let these cosmic questions carry you into dreams, where the boundaries between self and universe dissolve, where the distinction between before and after becomes meaningless, where the only reality is the eternal now of pure existence. And when you wake tomorrow, carry with you the wonder that brought us together tonight. Carry the knowledge that you're part of the universe's own journey of self-discovery, that every question you ask, every mystery you contemplate, every moment of awe you experience is part of the cosmos learning about itself. The question of what existed before the Big Bang will continue to evolve as our understanding deepens, as our instruments become more sensitive, as our theories become more sophisticated. But one thing will remain constant: the sense of wonder that drives us to ask these questions in the first place. And that wonder, that curiosity, that insatiable desire to understand is perhaps the most remarkable thing about our existence. It's what makes us human. It's what connects us to the cosmos. It's what transforms us from mere observers into participants in the greatest story ever told. As we drift deeper into sleep, let these cosmic mysteries wash over you like gentle waves. Let them carry you into dreams where anything is possible, where the universe is young and full of potential, where the question of what existed before the Big Bang becomes not a problem to be solved, but a mystery to be lived. And in that living, in that dreaming, in that gentle floating between consciousness and sleep, remember that you are part of the answer to the very question you're asking. You are the universe wondering about itself. And in that wondering, you become part of the eternal mystery that we call existence. Sweet dreams, fellow traveller in the cosmic dark. May your journey through the night be filled with stars and wonder, with questions that have no answers and answers that reveal new questions. For in the end, it's not the destination that matters, but the journey itself, the eternal quest to understand what it means to be part of this magnificent, mysterious, ever-unfolding cosmic story. The universe has always been a place of infinite patience, waiting eons for the right moment to reveal its secrets. And perhaps nowhere is this more apparent than in the recent discoveries about the cosmic microwave background radiation. This ancient light, the oldest electromagnetic radiation in the universe, carries within it the faint whispers of whatever processes preceded the Big Bang, like a cosmic fossil embedded in the very fabric of space itself. When we look at this radiation through our most sensitive instruments, we see tiny fluctuations in temperature, variations so small they amount to mere millionths of a degree. Yet these minuscule differences tell an extraordinary story. They appear to be the stretched out remnants of quantum fluctuations that occurred during the inflationary period, microscopic ripples in the fabric of reality that were inflated to cosmic proportions. Think of it like this. Imagine you have a balloon with tiny wrinkles on its surface. As you inflate the balloon, those wrinkles grow larger and larger, eventually becoming visible patterns across the entire surface. In much the same way, quantum fluctuations that were smaller than a proton during inflation were stretched across millions of light years, creating the temperature variations we observe today in the cosmic microwave background. These fluctuations are remarkable because they represent the seeds of all large-scale structure in the universe. Every galaxy, every cluster of galaxies, every vast cosmic web of matter that stretches across billions of light years can trace its origins back to these tiny quantum ripples that existed during or perhaps even before the Big Bang. We are quite literally seeing the fingerprints of creation itself, preserved in the ancient light that fills the universe. But here's where things become even more intriguing. The pattern of these fluctuations matches almost perfectly with the predictions of cosmic inflation theory. The statistical properties, the way they're distributed across the sky, the relationship between fluctuations at different scales, all of these details align with what we would expect if the universe underwent a period of exponential expansion before the hot, dense phase we call the Big Bang. This remarkable agreement between theory and observation gives us confidence that we're on the right track, that cosmic inflation really did occur. But it also raises profound questions about what drove this inflation, what existed in the quantum vacuum that gave rise to it, and what might have preceded even that mysterious epoch. Some of the most recent research suggests that the inflationary period might have been preceded by what physicists call a quantum tunneling event. Picture, if you will, a marble sitting in a valley surrounded by hills. In classical physics, the marble would need enough energy to roll up and over the hills to reach another valley. But in quantum mechanics, the marble can spontaneously tunnel through the hills, appearing on the other side without ever having enough energy to go over the top. In the context of cosmology, this quantum tunneling might have been the mechanism by which our universe transitioned from whatever state existed before inflation to the inflationary state itself. It's as if the universe tunneled from one quantum state to another, triggering the exponential expansion that set up the conditions for the Big Bang. This quantum tunneling could have occurred in a pre-existing space-time, perhaps in a universe that was already ancient by the time our cosmic neighborhood began to inflate. In this picture, what existed before the Big Bang was not nothing, but rather a vast, perhaps eternal, quantum field permeated by the constant possibility of spontaneous creation. The mathematics of this process are both elegant and mind-bending. They suggest that universes could be popping into existence constantly throughout an infinite multiverse, each one beginning with its own period of inflation, each one developing its own unique properties and histories. Our universe would be just one bubble in an infinite champagne of cosmic creation, forever separated from its siblings by the vast expanses of still inflating space. But let's pause for a moment to consider what this means for our understanding of existence itself. If universes can spontaneously tunnel into existence from the quantum vacuum, then the vacuum itself must be something rather than nothing. It must have structure, properties, laws that govern how these tunneling events occur. This brings us to one of the deepest mysteries in physics, the nature of the quantum vacuum. Far from being empty, the quantum vacuum is a seething sea of virtual particles, constantly popping in and out of existence, borrowing energy from the future and paying it back before the universe's accounting system notices. It's like a cosmic credit card with an infinite spending limit, as long as the bills are paid quickly enough. During inflation, this quantum vacuum played a starring role. The energy density of the vacuum itself drove the exponential expansion, stretching space faster than the speed of light. But here's the remarkable thing. This process didn't violate any laws of physics. The total energy of the universe might still be exactly zero, with the positive energy of matter and radiation perfectly balanced by the negative energy of gravitational fields. In this sense, the universe might be the ultimate free lunch, a spontaneous fluctuation in the quantum vacuum that grew into the cosmos we inhabit today. What existed before the Big Bang in this picture was the eternal possibility of existence itself, waiting patiently for the right quantum fluctuation to set everything in motion. Recent advances in string theory have added another layer of complexity to this picture. String theory suggests that the fundamental building blocks of reality are not point particles but tiny vibrating strings, existing in a space with more dimensions than the three we experience. These extra dimensions, curled up so small we can't detect them, might hold the key to understanding what existed before the Big Bang. In some versions of string theory, our universe is like a soap bubble floating in a higher dimensional space. The Big Bang might have been the moment when this bubble formed, when the extra dimensions compactified in just the right way to create the three-dimensional space we know. What existed before might have been a higher dimensional realm where different bubbles, different universes, are constantly forming and evolving. This higher dimensional perspective opens up possibilities that stretch the imagination. Perhaps there are universes where time flows backward, where the speed of light is different, where the fundamental forces have entirely different strengths. Perhaps there are universes made of dark matter, where the particles we consider exotic are common, and the particles we're made of are rare and mysterious. The ekpyrotic model, which we touched on earlier, suggests that our universe might have formed from the collision of two such higher dimensional surfaces, called branes. In this picture, what existed before the Big Bang was not a single universe, but a vast multi-dimensional space populated by these branes, occasionally colliding and creating new universes in the process. Imagine two vast sheets of reality floating through higher dimensional space, each one carrying its own physical laws, its own matter and energy. When they collide, the impact creates the conditions for a Big Bang, flooding both sheets with new matter and energy, resetting the cosmic clock and beginning a new chapter in the story of existence. This collision model is particularly elegant because it suggests that the Big Bang was not a unique event, but part of an ongoing process, a cosmic recycling system where universes are constantly being born from the interactions of higher dimensional objects. What existed before our Big Bang in this picture was simply the previous state of this eternal cosmic dance. But perhaps the most profound insight from these theories is that they force us to reconsider our most basic assumptions about the nature of existence. They suggest that reality might be far more fluid and dynamic than we ever imagined, that the boundary between existence and non-existence might be more like a gentle transition than a sharp dividing line. Consider the concept of quantum superposition, where particles can exist in multiple states simultaneously until they're observed. Some interpretations of quantum mechanics suggest that this superposition might apply to entire universes, that there might be cosmic states where multiple realities exist simultaneously until something causes them to collapse into a single definite state. In this quantum multiverse, what existed before the Big Bang might have been a superposition of all possible universes, a cosmic wave function that contained every possible history, every possible set of physical laws, every possible story that could ever be told. The Big Bang might have been the moment when this infinite possibility collapsed into the single, definite reality we inhabit. This idea resonates with ancient philosophical traditions that saw reality as fundamentally probabilistic, where the world we experience is just one actualization of infinite potential. But it also finds support in modern physics, particularly in interpretations of quantum mechanics that take seriously the idea that observation plays a fundamental role in determining the nature of reality. If consciousness is indeed required to collapse quantum superpositions, then perhaps what existed before the Big Bang was waiting for the first conscious observer to arise. In this picture, the universe might have existed in a state of pure potential until the first moment of awareness, the first instance of observation, caused reality to crystallize into the form we know today. This brings us back to the anthropic principle, but with a twist. Perhaps the universe isn't fine-tuned for consciousness because consciousness is special, but because consciousness is what makes the universe real. Perhaps we're not just lucky beneficiaries of cosmic fine-tuning, but active participants in the creation of reality itself. As we drift deeper into these theoretical waters, we encounter ideas that challenge not just our understanding of physics, but our understanding of what it means to exist at all. They suggest that the universe might be far stranger and more wonderful than we ever dared imagine, that the boundary between the possible and the actual might be more permeable than we thought. These ideas also remind us that we're still in the early stages of understanding the deepest mysteries of existence. We've barely begun to explore the implications of quantum mechanics, string theory, and cosmology. We're like children who have just learned to read, sounding out the first few words of a cosmic library that contains infinite volumes. But perhaps that's exactly as it should be. Perhaps the universe is designed to be inexhaustible, to always offer new puzzles and new wonders to explore. Perhaps the question of what existed before the Big Bang is not meant to be definitively answered, but to be lived with as a reminder of the vast mystery in which we find ourselves embedded. And in that living, in that wondering, in that gentle pursuit of understanding, we find something that transcends the boundaries of science and philosophy. We find meaning, purpose, connection to something larger than ourselves. We find our place in the cosmic story, not as passive observers, but as active participants in the universe's ongoing journey of self-discovery. As we continue to drift through these cosmic contemplations, remember that every question we ask, every mystery we contemplate, every moment of wonder we experience is part of this journey. Through our curiosity, our observations, our dreams and aspirations, we're helping to write the next chapter in the story of existence itself. The universe has waited billions of years for beings like us to arise, for consciousness to emerge from matter, for matter to emerge from energy, for energy to emerge from the mysterious quantum foam that bubbles at the foundation of reality. And now that we're here, now that we're capable of asking these profound questions, we've become partners in the cosmic adventure. What existed before the Big Bang may always remain a mystery, but it's a mystery that connects us to the deepest questions of existence. It reminds us that we're part of something magnificent, something that extends far beyond our individual lives and experiences. It connects us to the eternal human quest for understanding, to the cosmic story that began with the Big Bang and continues to unfold in every moment of our existence. So as we drift towards sleep tonight, with these cosmic questions floating through our minds like gentle stars, remember that you are part of the answer to the very question you're asking. You are the universe wondering about itself, existence contemplating its own existence, consciousness arising from the very mystery it seeks to understand. And in that wondering, in that contemplating, in that gentle floating between wakefulness and sleep, you become part of the eternal mystery that we call existence. You become part of the story that began before the Big Bang and will continue long after our individual chapters have ended. You become part of the cosmic dance that connects all things, the eternal rhythm that beats at the heart of reality itself. Sleep well, fellow traveller in the cosmic dark. May your dreams be filled with infinite possibilities, with questions that open new doors and answers that reveal new mysteries. For in the end, it's not the destination that matters, but the journey itself, the eternal quest to understand what it means to be part of this magnificent, mysterious, ever-unfolding cosmic story. And perhaps that's the most beautiful truth of all, that in our quest to understand what existed before the Big Bang, we discover something profound about the nature of existence itself. We learn that reality is not a fixed stage upon which events unfold, but a dynamic, ever-changing tapestry woven from the threads of possibility and actuality, consciousness and matter, time and space. The ancient philosophers spoke of the eternal return, the idea that all things come back in endless cycles. Modern physics whispers something similar through the mathematics of eternal inflation and cyclic cosmologies. Perhaps what existed before the Big Bang was simply another verse in an infinite cosmic song, another movement in a symphony that has no beginning and no end. But here's what makes this mystery so deeply personal. We are not separate from the question we're asking. The atoms in our bodies, the thoughts in our minds, the wonder in our hearts, they're all part of the same cosmic story that began with the Big Bang, and perhaps with whatever came before. We are the universe's way of experiencing itself, of contemplating its own existence, of asking the very questions that define the boundaries of the known and unknown. In the gentle rhythm of your breathing right now, in the steady beating of your heart, in the electrical patterns dancing through your neurons, you carry the legacy of that primordial moment when everything began. You are living proof that the universe is not just a collection of lifeless matter and energy, but a creative force capable of giving birth to consciousness, to beauty, to love, to the very capacity for wonder that brought us together tonight. The question of what existed before the Big Bang may never find a final answer, but it serves a purpose that transcends any particular solution. It reminds us that we live in a universe of infinite mystery, where every answer reveals new questions, where every discovery opens new horizons, where every moment of understanding brings us face to face with the vastness of what we don't yet know. And maybe that's exactly as it should be. Maybe the universe is designed to be inexhaustible, to always offer new puzzles and new wonders to explore. Maybe the deepest questions are not meant to be answered, but to be lived with, as companions on our journey through the cosmic dark. As we drift deeper into sleep tonight, let these cosmic mysteries wash over you like gentle waves. Let them carry you into dreams where time has no meaning, where the boundaries between self and universe dissolve, where the question of what existed before the Big Bang becomes not a problem to be solved, but a mystery to be embraced. Remember that you are part of this magnificent story, this cosmic adventure that began 13.8 billion years ago and continues to unfold in every moment of your existence. Through your dreams, your thoughts, your very being, you're participating in the universe's ongoing conversation with itself. The stars above you tonight are the same stars that have watched over countless generations of humans who have asked these same questions. The carbon in your cells was forged in the hearts of those dying stars, connecting you to the deepest history of the cosmos. You are not just in the universe, you are the universe, experiencing itself through the miraculous phenomenon of consciousness. So rest easy, knowing that you're part of something that extends far beyond the boundaries of space and time. Let the mystery of what existed before the Big Bang become a gentle lullaby, a reminder that existence itself is the most extraordinary gift, the most improbable miracle, the most beautiful accident, or perhaps not an accident at all, but the inevitable flowering of some deeper pattern we can barely glimpse. And as you drift off to sleep, carry with you the knowledge that tomorrow the universe will continue its ancient dance of creation and discovery. New stars will be born, new galaxies will form, new possibilities will emerge from the quantum foam, and somewhere in that vast cosmic ballet, your own small but precious existence will continue to add its unique note to the eternal symphony. The question of what existed before the Big Bang will be there when you wake, as mysterious and beautiful as ever. But tonight, it's enough to know that you're here, that you are part of the answer to the very question you're asking, that you are the universe's way of wondering about itself. Sleep well, dear traveller in the cosmic dark. May your dreams be filled with infinite possibilities, with gentle mysteries that comfort rather than trouble, with the quiet joy of being part of something magnificent and eternal. For in the end, perhaps that's what existed before the Big Bang, the eternal possibility of moments like this one, where consciousness touches the infinite and finds it beautiful. And so, dear fellow researcher, we find ourselves at the end of our cosmic journey, though perhaps end is not quite the right word for a story that stretches back to the very dawn of existence, and perhaps beyond. We've drifted through theories of inflation and quantum tunneling, floated past cyclic universes and eternal multiverses, contemplated the possibility that reality itself might be a hologram, a simulation, a mathematical structure dancing in dimensions we can barely imagine. We've asked what might be the most profound question humans have ever posed: what existed before the Big Bang? And while we haven't found a definitive answer, we've discovered something perhaps even more valuable. We've found that the question itself opens doorways to wonder, to possibility, to a deeper appreciation of the magnificent mystery in which we find ourselves embedded. Through our gentle exploration tonight, we've seen that the universe might be far stranger and more beautiful than we ever dared imagine. Whether it emerged from a quantum fluctuation in an eternal vacuum, whether it's one bubble in an infinite multiverse, whether it arose from the collision of higher dimensional brains, or whether it's something else entirely, the story remains breathtakingly extraordinary. Perhaps what existed before the Big Bang was simply the eternal capacity for existence itself, the timeless possibility that something rather than nothing could emerge from the deepest levels of reality. Perhaps it was pure mathematics, waiting to be actualized. Perhaps it was consciousness itself dreaming the dream we call the universe. Or perhaps it was something so fundamentally different from anything we can conceive that our questions themselves are like asking what colour Wednesday tastes like. But here's what we do know, what we can hold on to as we drift towards sleep. We are part of this story. The atoms in your body were forged in the hearts of dying stars. The thoughts in your mind are patterns of energy that emerged from the same quantum processes that gave birth to galaxies. You are not separate from the universe you're contemplating. You are the universe contemplating itself. In your curiosity about what existed before the Big Bang, you're participating in the cosmos's own journey of self-discovery. Through your wonder, your questions, your gentle pursuit of understanding, you're helping to write the next chapter in the story of existence itself. You are living proof that the universe is not just a collection of lifeless matter and energy, but a creative force capable of giving birth to consciousness, to beauty, to the very capacity for wonder that brought us together tonight. And perhaps that's the most beautiful answer of all. Perhaps what existed before the Big Bang was the eternal possibility of moments like this one, where consciousness touches the infinite and finds it not cold or empty, but warm with meaning, rich with mystery, alive with endless potential for discovery and understanding. The question will continue to evolve as our knowledge deepens, as our instruments become more sensitive, as our theories become more sophisticated. Future generations may find answers we can barely imagine, or they may discover that the mystery goes even deeper than we thought. But one thing will remain constant: the sense of wonder that drives us to ask these questions in the first place. So as you settle into sleep tonight, carry with you the knowledge that you are part of something magnificent. Let the mystery of what existed before the Big Bang become a gentle companion, a reminder that existence itself is the most extraordinary gift. You are the universe's way of experiencing wonder, of contemplating beauty, of asking the deepest questions about the nature of reality. Wherever you are in the world, whatever time it is in your corner of the cosmos, thank you for joining me on this journey to the very edge of existence. If you've enjoyed this gentle exploration through the deepest mysteries of the universe, I'd be ever so grateful if you gave the video a like and perhaps subscribe to join our growing community of weary researchers. It helps more curious minds like yours find their way to these peaceful journeys through the cosmos. And now, as we drift toward the end of our time together, let me leave you with one final thought. The universe has waited 13.8 billion years for beings like us to arise, for consciousness to emerge from matter, for matter to emerge from energy, for energy to emerge from whatever mysterious realm existed before the Big Bang. And now that we're here, now that we're capable of asking these profound questions, we've become partners in the cosmic adventure. So rest easy tonight, knowing that you are part of the answer to the very question you're asking. You are the universe wondering about itself. And in that wondering, in that gentle contemplation, in that quiet drift between wakefulness and sleep, you become part of the eternal mystery that we call existence. Sleep well, fellow traveller in the cosmic dark. May your dreams be filled with infinite possibilities, with gentle mysteries that comfort rather than trouble, with the quiet joy of being part of something that extends far beyond the boundaries of space and time. For in the end, perhaps the most profound truth is this: we are all children of the stars, born from the same cosmic fire that lit the first moment of creation, carrying within us the memory of whatever came before, and the promise of whatever comes next. The question of what existed before the Big Bang will be there when you wake, as beautiful and mysterious as ever. But tonight, it's enough to know that you are here, that you are part of this magnificent story, that you are the universe's way of wondering about itself. And in that wondering, in that gentle floating between consciousness and sleep, you become part of the eternal dance that connects all things, the timeless rhythm that beats at the heart of reality itself. The universe has been patient with us, waiting eons for creatures capable of asking such questions to evolve from stardust and time. And now that we're here, now that we've developed the mathematics and the instruments and the sheer audacity to peer back toward the very beginning of everything, we find ourselves not with answers but with deeper mysteries, more beautiful questions, more profound appreciation for the extraordinary nature of existence itself. Perhaps that's the most honest thing we can say about what existed before the Big Bang. We don't know, and we may never know with certainty. But in our not knowing, we discover something remarkable about the human spirit, about consciousness itself, about the universe's capacity to wonder about its own origins through the eyes and minds of beings like us. The theories we've explored tonight, from cosmic inflation to cyclic universes, from quantum tunneling to eternal multiverses, they're all attempts to push back the veil of mystery just a little further. Each one opens new possibilities, new ways of thinking about the nature of reality, new appreciation for the delicate balance of forces that allows stars to shine and planets to form and life to emerge from the cosmic dark. But perhaps the most profound insight is this: the question itself transforms us. In asking what existed before the Big Bang, we're not just seeking information about the past. We're participating in the universe's ongoing conversation with itself. We're helping to write the next chapter in a story that may have no beginning and no end, only eternal transformation, endless creativity, infinite possibility. And so, as we drift towards sleep tonight, let these cosmic mysteries become gentle companions rather than troubling puzzles. Let them remind you that you are part of something magnificent, something that extends far beyond the boundaries of individual existence. The carbon in your cells, the oxygen in your lungs, the iron in your blood, they were all forged in the hearts of dying stars, connecting you to the deepest history of the cosmos. You are not just in the universe. You are the universe, experiencing itself through the miraculous phenomenon of consciousness. Through your dreams tonight, through your thoughts and wonderings, through the simple fact of your existence, you're participating in the most extraordinary story ever told. The question of what existed before the Big Bang may never find a final answer, but it serves a purpose that transcends any particular solution. It reminds us that we live in a reality of infinite depth, where every answer reveals new questions, where every discovery opens new horizons of mystery and wonder. So rest easy, knowing that you are part of this cosmic adventure. Let the mystery of what came before the beginning become a source of comfort rather than anxiety, a reminder that existence itself is the most improbable gift, the most beautiful accident, the most extraordinary flowering of whatever deeper pattern gave birth to everything we know and love. And as you drift off to sleep, carry with you the knowledge that tomorrow the universe will continue its ancient dance of creation and discovery. New stars will be born, new galaxies will form, new possibilities will emerge from the quantum foam that bubbles at the foundation of reality. And somewhere in that vast cosmic ballet, your own precious existence will continue to add its unique note to the eternal symphony. The stars above you tonight are the same stars that have watched over countless generations of humans who have asked these same profound questions. You are part of an ancient lineage of wonder, a cosmic conversation that began the moment the first conscious being looked up at the night sky and asked where it all came from. Whether what existed before the Big Bang was an eternal multiverse, a quantum vacuum, pure mathematics, or something else entirely beyond our current understanding, one thing remains beautifully clear. It gave birth to this moment, to this experience, to the capacity for wonder that allows us to contemplate the deepest mysteries of existence. So sleep well, dear traveller in the cosmic dark. May your dreams be filled with infinite possibilities, with gentle mysteries that inspire rather than trouble, with the quiet joy of being part of something that extends far beyond the boundaries of space and time. For in the end, perhaps the most profound truth is this: we are all children of whatever came before, carrying within us the memory of that primordial moment when everything began, and the promise of whatever discoveries await us in the vast unknown. The question of what existed before the Big Bang will be there when you wake, as mysterious and beautiful as ever. But tonight, it's enough to know that you are here, that you are part of this magnificent story, that you are the universe's way of wondering about itself. And in that wondering, in that gentle drift between consciousness and sleep, you become part of the eternal mystery that we call existence. Good night, fellow explorer of the infinite. May your rest be peaceful, your dreams be filled with stars, and may you wake tomorrow with renewed wonder at the extraordinary privilege of being conscious beings in a universe that gave birth to consciousness itself. The greatest mystery of all may not be what existed before the Big Bang, but that anything exists at all, that out of whatever primordial depths gave birth to reality, something as beautiful and improbable as you came to be.